We've been given a rare opportunity to get behind the doors of a boat building business and see exactly how they turn out their product. The Polycraft guys have kindly opened the doors of their factory. They're going to show us firsthand how they go about making their great product. Get the high-vis vest on, let's get behind those doors, come on. Like many of the products we use today, Polycraft boats start their life in the ground. Natural gas companies collect gas and then use it to create other products like ethane and methane, which is then used to create further products like ethylene. And that's the starting point for polyethylene. The Polycraft guys use virgin grade marine polyethylene as the starting point for their boats. It comes in a pellet form, and that product is then sent on to someone else to further create the product, which is used to finally make Polycraft boats. The virgin grade, marine grade polyethylene is then UV stabilised. Sunscreen added to it to protect your boat when it's out in the sun. That product is then sent to another company that puts it through the process of adding some secret herbs and spices. It makes it further stable for the Australasian environment. It's 100% recyclable at that stage. It also adds some colour and it comes back in powder form, a bit like you see in your washing powder at home. That product is then ready for the moulding process. Poly Industries make Polycraft boats, but they also make a range of water tanks. They're a top quality product and one that you're probably familiar with using every single day. These rotating moulds in this area of the factory are used to make all the internal components of the boats, as well as the 3-metre tough tender. We're now looking at a mould for a Polycraft boat. Ant's about to fill this with powder, the Roto-moulded product we spoke about before, put the skin on top, stick it in the oven and mould us a boat. Ready, mate? Show us how it's done. After your boat's been cooked for a while, she's removed from the oven and placed on the floor. The next step is unclamping those moulds. Then the boat is lifted, slid across and placed into the racks to cool and settle for a while. Your boat's now come out of the mould, and depending on how you want it set up, these guys will fit it out to your exact requirements. If you're concerned about the heat-resistant qualities of polyethylene plastic, let's take a test. First, let's try and burn through a piece of metal. And then, let's see how long it takes us to burn through a piece of polyethylene plastic. Bowl of hydrochloric acid, piece of polyethylene, colour-coded for our green Polycraft boats. I'm going to throw that in the acid first and see what happens. Happily floating away, stable as you like. And now, the next piece, we're going to throw a piece of metal in there and see exactly what happens. It's a bit like throwing the old aspirin into me cup of water. She's starting to fizz and carry on. Side by side, it's quite impressive. And there you have it, a piece of metal, a piece of polyethylene plastic thrown into some very, very nasty chemical. Easy to see which type of material is going to handle the rigours of the Australasian environment. I always find it interesting when I hear of people being cautious about considering purchasing a plastic boat, when so many of the everyday household items we use are made of plastic. We're completely comfortable with using so many of these things like pegs, DVD covers, household products. All of them made in plastic, and we have utter faith in them. So why not consider a plastic boat, because they come with so many benefits that can help you when you're out on the water. The Polycraft boats come equipped with a really soft ride, and that has a lot to do with the properties of the material that's used to make them. A good example to explain how this works is it's a little bit like a shock absorber in a car. But if you were to squeeze your plastic bottle, it's soft, it's cushioned, but it flexes back to its original shape. It's got a memory. Same thing happens in your Polycraft hull. You can obviously see here we've got the dual skin, and if I squeeze it, you'll notice that the boat's flexing. Now when you're out on the water, punching through a bit of chop, copping some vibration, that hull is working in your advantage. Flexing in and out, giving you that shock absorption, which gives you that wonderful, quiet and soft ride when you're out there enjoying a day on the water. It's worth spending a bit of time understanding the dual skin hulls that you get in a Polycraft boat. It's a one-piece construction hull, so that means there's no seams, no welds, no joins, which makes it very strong. The other benefits which come with this hull, obviously, as you can see here, we've got a cavity that, for some reason, if you do happen to penetrate that outer skin, you've still got great buoyancy and flotation, which is offered by that inner skin. Another benefit, we can run a lot of our wiring in a boat, obviously to keep it out of the way, out of the weather, and also out of the way of your feet and your fishing and play space. And the other real big benefit, obviously you get that flex, softens your ride, gives you that shock absorber effect. All in all, what a wonderful design that gives you so many benefits when you're out on the water. Let's have a bit of a science experiment, and one that looks at the buoyant properties of polyethylene, the stuff that's used to make Polycraft boats. Firstly, we've got our bowl of water. I'm going to throw my bit of polyethylene in there. It's neutrally buoyant, sits on top of the water. If I want to add a little bit of force to that, push it to the bottom, it's going to rise back up to the top. And there we have something that's neutrally buoyant. On the other hand, grab a bit of metal, throw it in there, not coming back up. All right, sinks like a stone. There we have two materials. One which we make the Polycraft boats in, neutrally buoyant. Another one that sinks when thrown into the drink. Let's run you through a quick test of just how strong the material that's used to make Polycraft boats is. Equipped with your standard hammer, fully weighted, and I'm going to use the pointy end to do this. I'm going to hit this as hard as I can and see if I can put a dent into it. I have slightly marked that with 3 of my best hits. That says a fair bit about just how strong these boats are. Okay, now for strength test number 2. I've upped the ante just a little bit. Come equipped with a sledgy. I'll see if I can put a bit more imprint on this than I did with your standard hammer. You ready? That's another 3 of my best. All that's happened is I've pushed this half hole across the room, and I don't even think I've dented it. I think I've actually left a bit of rust off the sledgy on the side of the boat, and that's about it. Good luck finding a tougher boating material on the market than that. As part of meeting an Australian standard for quality assurance and control, they have to test the integrity of the final moulded polymer product. To properly test the integrity of the material, it first has to be frozen to -40 degrees. Here we've put a piece of frozen clinker into the testing device prior to striking it with a sharpened hammer. The next step of the process is striking the material with 135 joules of force. Today, rather than test tank material, we've chosen to test some of the clinker which you see in the Polycraft range of boats. Having dropped the hammer, all we can see is a slight divot left in our frozen piece of clinker. 1 in 10 tanks have to be tested in this fashion. Now it's time to carry out the same test on a piece of 1.6mm metal. As you can see, dropping the hammer resulted in severe degradation of the integrity of our piece of metal. Now let's up the ante and increase the rate of joules and just see what happens to our piece of plastic and then our piece of metal.